Hi there, my name's Rob Persons. I'm a senior sales architect with Smart Embedded Computing. And you're going, who the heck is Smart Embedded Computing? We're going to show you who that is. And Jerry, I'm going to be over by about 5-10 minutes just so you can't get to lunch early. What I'm going to talk about today is really kind of a departure from some of the more technical types of application notes, if you want to call it that everybody's been talking about. We're going to talk about a real life situation that we've been dealing with over the last year, really around supply chain security. And we've heard last year was very popular. A lot of people were talking about possible approaches to it. We're living it right now with a certain product. So I'm going to discuss a little bit about it and show you some of the real life scenarios affecting it. First, a little bit about Smart. We were actually Smart Embedded, or Smart Global Holdings is really primarily was a bunch of memory modules, storage devices. I suspect people in here have actually probably used Smart Module products in the past. They had this, and they've been doing that since '88. They added a business within Brazil, focusing on the Brazilian market, primarily around mobile devices. They sell other things there too. They'll sell just straight memory devices, but a big part of the business is mobile, including batteries and things like that. And they were dealing with the trials and tribulations of how the memory market is. It's very punctuated on how well it's doing and how poorly it's doing. And so they were trying to level that off and started to add some embedded computing companies along with some HPC company to try to mellow it out a little bit and actually move up the food chain for products. So they acquired a HPC company called Penguin Computing. They do very large scale, high performance computing systems for labs, for big primes, things like that, for doing simulation and all sorts of things. And then they acquired us in 2019, along with another small module company called Inforce Computing, to try to kind of move around away from just being in an enterprise class environment to more federal types of applications. And that's how we became part of Smart Embedded Computing. Heritage, let me see if you didn't change it. I thought you said you're going to change this for microsystems. So Jerry told me I had my chart wrong, of course, since he was there before I was there for the very early stages. But this is really kind of the history of who embedded computing is. And it's really an amalgam of a whole bunch of different companies. There's people out in this audience that have been part of the acquisition to lead to this point. The last acquisition we went through prior to Smart was actually being part of a private equity firm in 2013, and we became Artisan Computing at that point. And then those assets were purchased by Smart in the 2019 timeframe. So we're 6 months within Smart right now. So the bulk of the presentation is really to talk about what's been happening over these years with specifically around some Navy adoptions. We sell very heavily into the Navy, systems I've spoken about in the past, excuse me. And I'm trying to show you kind of how we got to the point today on some of the supply chain issues that we've been running into. Very early time in the 80s, they were used to use very purpose-built computers. This is a Honeywell system, the Yuck 43. Which were fine for that level of computing, but it was very slow to change, and they were kind of really tied with a single manufacturer of products. In the 90s, that migrated into the first evolution of COTS, and that's where the term started, is really in the kind of the 90s timeframe, when they started using things like VME for those same applications, trying to separate themselves and be part of an ecosystem of products, so they can buy products from a variety of vendors. That actually transitioned into even more enterprise type products with bladed architectures, but again, not specific to VME, but just in a general purpose processing. Along the whole time frame, they were also moving their software infrastructure into something called an open systems architecture, which really was to abstract themselves away from the underlying hardware and to make it so that they could move very dynamically to a variety of companies. We became involved again. We were there back in the 90s, and we're back again into this program in 2015. And this, again, was kind of moving back to an open standards version, but really, this software that was developed on these early systems in 2004 really migrated quite nicely. Makes it very easy for them to be able to add new feature set and do things like that. But along with this process of moving to more commercial types of applications, they started to have to start to deal with the fact that these products are not just built in the US. Products are built in these commercial space all over the world, and a lot of them are built in China. So they had some reservations about the fact that that was the case, but they understood they've been buying laptops and servers and routers for years and said, okay, we'll deal with that. But then in 2018, Bloomberg came out had that big hack article talking about the potential of injection of anomalous things into designs that are just built in China. There's been plenty of discussion about how that's probably didn't happen, but it raised the concern within our customer that things that are built in China are problematic. So we had a meeting back in 2018 with the captain that controls the entire weapons program. He came in to discuss. We were there to go and reassure him that our supply chain is safe and secure, and actually did a very detailed presentation to discuss how secure our supply chain is. We discussed the general approach that we take with just our overall approach to supply chain between dealing with our vendors, dealing with design specifications, and how we control all this down to our production and our manufacturing. We gave them detailed presentation on our engineering processes and how we actually approach this. All our design is done in the US, software and hardware, and we convinced them that we're trying to convince them that this was sufficient and that the control of the supply chain part of it, which was in China, could be handled. So we actually went through some very detailed design specifications on how do we go and build products? How do we acquire components? How do we decide what components go on these boards? How do we control software that runs on these boards in our systems? And went through a very detailed process of the supply chain side and also product life cycle. And what do you do when you have an end-of-life component? Because all our parts are long-life products like everyone else does in this space. How do you deal with those component changes and re-verify the application and the design? And we actually have a white paper that was just released this month if you want more details on what the processes we do to actually affect a secure supply chain. They said, that's great. But what if we're in a shooting war? Essentially what he said is, what if we're in a shooting war where your products are being manufactured? So our manufacturing facility was in China. And he says, you own the facility, you own the supply chain, but how do we guarantee that we'll get that product if we ever get into conflicts? And it was a very valid point. So one of the things that they wanted, and we were already prepared for because we knew they're heading this way, is to go and repatriate that product line. So we repatriated the hardened ATCA products that we do for them back to a contract manufacturer, an ITAR-based contract manufacturer in the US. We did the move in 2 quarters and brought their systems back up on purchasing ability to buy the systems within a couple of quarters. It's a pretty significant kind of tough thing, especially this happened in like the fall of 2018, and we went through Chinese New Year, so we had to do the transition with that and all that sort of stuff. So, but we got that completed. Then in July 2019, we were purchased by Smart. Smart said, that's great that you have this capability in the US. We also have a capability in the US. So they actually have US-based manufacturing, and we're now in the process of moving it again from that contract manufacturer to the Smart facility in California. The remaining products that we have will go to a Smart-based manufacturing facility in Malaysia. So some things we still produce in a low-cost kind of design or manufacturing facilities. The fact that it's out of China helps with a lot of our customers, in fact. So then we started to look beyond just manufacturing these products, because a big part of this is how do you secure the product itself, design techniques to help improve the security of these products, and also start to look at the underlying components that are put on this product. So it's great that you can say, well, your products are manufactured in the US. What about what about the components that are actually going on there? What if we're having to source those from China itself? And so we started to analyze that in the process, especially for some brand new designs that we're doing for this product family. So the first thing we did was we actually started a new design on these boards with the idea that we need to secure the products more down on the board itself. There's actually normal sorts of things that you can do for the operating systems, like doing certificate-based booting, those sorts of things that are fairly straightforward. But we had a big part of it that was really still available to kind of infection, if you want to call it that, around the BIOS itself and the IPMC firmware. So we've actually have a cyber FPGA that's on this board, being designed on this board to actually secure the firmware images and also protect against malicious activity on the buses themselves that are used for BIOS updates and IPMC flash updates. So then we started to look at the component side of this picture. Can we build a board that doesn't source anything from China? The processors, all the different pieces that go on these things. We found we had mixed results with this. In general, some of the components have multiple production facilities, so that was pretty straightforward. We could just designate, we want parts that come from this part of the world. Others had limited sourcing opportunities, and we saw that the biggest problem that we had was really with the mechanical parts. They gave us the most trouble, and we're still working through that right now. So here's kind of a real-world sourcing example between the two products of what we saw. You don't have to read through all this, but I'll tell you the biggest problem that we saw were with mechanical parts, especially electromechanical parts. It's very, very difficult to source those. Then it becomes a discussion around, well, what do you do? Do you go and contract? Do you do a specialized part? That becomes very problematic if you now have to own the design for a part. It's much easier actually getting those parts from those sources. So we're doing some discussion with our customers today about it to try to figure out how do we deal with this. How important is a dip switch? Do you consider that a real issue? With being able to source these boards. In general, I think that the opinion we're getting is that try to do do the best you can. And for those things that are really impossible, just don't worry about it. And eventually, if it really becomes a problem, then you can just go and contract out those parts in the future. So in conclusion here, so that we can protect the warfighter and these tactical systems, there's many faceted pieces to this, as it turns out. Managing where the product is manufactured is one big part of it. Focus on securing the design. Improving the overall cybersecurity of the product itself. You still have to have good comprehensive supply chain process, and how do you manage your components for a long life. There's a big deal of effort that goes into analyzing what components can be sourced away from China, but there were a lot of trade-offs, and I think we kind of caught them off guard by this, because we're asking them, okay, give us your opinion on how to go and move forward, and they're still reeling from the idea of actually trying to force this situation, because it's a balance between actually being comfortable with where these parts are sourced, but also not eliminate some of the advantages of what COTS has brought along with this picture, which is being able to stay on a technology curve and have an easy supply of products and not have 20-week lead times and things like that. So in general, this has been a kind of a learning experience for us, and I think we'll get better as time goes on, and these are experiences that we saw.